Today I'm going to explain to you what a Kaplan-Meier curve is. So if you have a bunch of animals and they are all dying at different times, it's often hard to tell what we should be measuring to look at longevity. You could look at when the oldest animal dies, which is called maximum lifespan, and that's telling you something about the extreme of the population. But if 9 out of 10 animals die at age 1 and one animal lives to be 100, maybe that's not the best metric for a thing that we want to optimize for. You could alternately look at the time when 50% of the animals are dead. So this would give you some sense for when your kind of average animal would expect to die, which is actually different from the average lifespan. That is the weighted sum of the lifespans of all the animals, and will give you a number that is some reflection of a mean, but might not actually be close to the kind of lifespan that the 50th percentile animal experiences. So basically, none of these methods gives you the clearest picture, and one way to kind of get just a pure sense for the population lifespan is look at the curve of survival over time. So on your y-axis, you can have the number of animals that are still alive, and on the x-axis, you can have the time of their lifespan. Now the problem with this method is if a bunch of animals ran away on day 8, you might see a huge drop in the number of animals still alive, but they wouldn't have actually all died, they would have just been censored, what we call censored, which is removed from the population under consideration. So a way to get around this is with a Kaplan-Meier curve. In a Kaplan-Meier curve, each time point is updated based on the number of animals that are still alive out of those that we could consider to be potentially still alive at each time step. Specifically, if on day 3, 5 out of 10 animals run away, then we would update the prior percentage of animals still alive by multiplying it by 1 minus the number of animals that died out of the 5 remaining over the number that we considered as part of the population, which is 5. So if 5 animals run away and none of the remaining animals die, then our curve is still horizontal. If, on the other hand, a bunch of animals died out of those remaining population, then we update the curve based on that. But it's not biased by the censored animals. Now, of course, this method has its limitations. It sometimes hides if a bunch of animals are censored at any one time point, and so you don't pick up on important discrepancies in the data. But nonetheless, it's a fairly good place to start, and will give you some rubric for whether, for example, there's one animal that's living incredibly long, but biasing the population because most animals don't.